Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the alkaloid extraction and the purification method of alkaloids that we have seen, as well as along with we also discuss general properties of alkaloids. What are the general properties of the alkaloid? That also we have discussed, and today right now we are going to discuss about some alkaloids, their sources and uses. So that is the point we are discussing right now. For that, their sources and uses, from where that alkaloids are obtained or derived, and what are their uses, and in the property we have seen these alkaloid shows the physiological action when it is used in a small amount, it acts as a medicine. So that is the main property of that alkaloids. Let us see some of the alkaloids, their sources and uses in a tabular form. Let's see here some alkaloids, their sources and uses. Let us see in the table. We are going to take in the first column alkaloids, that is a alkaloids, and in the second column contain molecular formula of that alkaloid. In the next column, sources, what are the sources of it, and in the next column we are going to see the properties and uses, properties and uses. In this tabulate form we are going to learn some of the alkaloids here one by one. Let us see. First one is a ephedrine. That is the first one we are going to learn. That is a ephedrine. Ephedrine, it is one of the first alkaloid in at a T.Y.B.Sc level we are going to discuss. That is a ephedrine. Let me clear the spelling of that ephedrine is something ephedrine. So that is the spelling of that alkaloid. Ephe, not I. There must be as a E. Ephedrine. So that is the name of that alkaloid, and it has a molecular formula C10H15NO. The molecular formula of that ephedrine C10H15 and NO. As we know that alkaloids are containing nitrogen atom, and that's why they are basic in nature. In general, those organic compounds containing nitrogen atom are basic in nature. The reason behind it, they containing as a lone pair of electron. According to as a Levy's base, acid base theory, they are capable of donating the lone pair, means a substance which can donate the lone pair of electron, that substances are known as a bases. This is the simplest definition according to as a Levy's acid base concept. That time we know that, and according to that, here if you observe this molecular formula carefully, what do you see over here? It containing as a nitrogen atom, and therefore ephedrine is a basic in nature. Now in the next sources, from where it is obtained, it is a genus ephedra. It is a genus ephedra. Source of it is a genus ephedra. From this plant we can extract or we can obtain this ephedrine. And what are the properties and uses of this? Let us see. It is a heart stimulant used in hay fever and asthma. Heart stimulant, property of this ephedrine, main property of this, it is a what we can call it as a heart stimulant. It is a heart stimulant. This is the main property of that ephedrine, and the uses of this, it is used in hay fever, used in hay fever. The spelling of hay fever is this one, H-A-Y, hay fever, F-E-V-E-R, hay fever and asthma, hay fever and asthma. So this is the property as well as uses of this ephedrine. It is one of the, what we can call it as alkaloid. If it is taken in a small amount, then it can act as a medicine, as we know that. And now second one is a ricin. Second one will be the ricin. Second one will be ricin. So that is the name of that alkaloid, and that ricin has a molecular formula is CH8N2 and O2. This is the molecular formula of that ricin, C8H8N2 and O2. This is the molecular formula of this ricin and the castor bean seed. It is present in castor bean seed. Castor bean bean seeds. It is occur in a castor bean seeds and the less toxic than other alkaloid. It is a less toxic. It is a less toxic than other alkaloid. Less toxic than other alkaloids. This is a speciality of the its properties and uses. Now let us see the next one is a conine. Third one will be the conine. It is a alkaloid and it has a molecular formula C8H17N. S17N, which is the molecular formula. Remember, whenever there is a nitrogen atom, then there is always odd number of hydrogen atom present in the molecular formula, that you should remember. Next point, look at here, only one nitrogen atom, therefore hydrogen atom are 15. Here only 17 hydrogen atom, therefore only one electron. Look at here, 2 nitrogen atoms are there, therefore even number of hydrogen atom involved in the molecular formula. That is the general thing you should remember while knowing the molecular formula, because these formula we are going to use. From molecular formula we are going to calculate the number of sites of unsaturation present in the unknown compound while solving the problem based on spectroscopy like UV, IR and the NMR. Combining study of these 3 spectroscopy, we are going to determine the structure of the organic compound, and that is a very new and the interesting topic introduced at T.Y.B.Sc level. So that we are going to discuss after the completion of this chapter. So why it is important and the interesting you will find during the study of that spectroscopic method. So let us see here once again that the source of this is a hemlock. This is a hemlock. It is a name of that plant from where it is getting hemlock, that is a Conium maculatum. Conium maculatum, that is the name of that. So conicum, and maculatum. This is a name is given in the bracket, and the properties, that is a paralysis. The central nervous system, CNS, central nervous system causes death. Central nervous system causes death. So this is the what we can call it as their property of this alkaloid. Let us see fourth one is a piperine. Piperine. So that is another name of that alkaloid, and it has a molecular formula C7H19NO3. C7H19NO3, which is the molecular formula of that piperine, and the sources from where it is obtained, it is generally obtained from black peppers. Black peppers in bracket, generally the piper nigrum, which is the what we can call it as a that is a name of that plant. Less toxic, optically inactive. It is a less toxic, optically inactive. These are the properties of this ephedrine. And now let us look at as a fifth one. Fifth one is a nicotine. And you might have heard this word nicotine, which is present in the tobacco. The name of this, the source from here, tobacco, which is a name of this. Here the molecular formula of that nicotine will be C10H14N2. C10H14 and N2. It is obtained from tobacco. And that tobacco generally is Nicotina tobacum. Nicotina tobacum, and the properties of it is deadly poisonous. Increases blood pressure. Increases blood pressure, or you can call it as a BP. Now sixth one is a atropine. Sixth one will be atropine, and it has a molecular formula is C12H23NO3. C7H23NO3, which is a molecular formula of this H17 carbon 17H23 carbon 17H23NO3. The molecular formula Atropa belladonna. Dhatura, it is Dhatura, not D, not H, DA, Dhatura, Hycamus, Niger, and the properties of this is a strong poison, dilation of the pupils of the eyes of cats, and then conine, erythro, xylone, coca, and its property, its hydrochloride salt is used as a local anesthetic in eyes surgery and dentistry. Then quinine, it has a molecular formula C20H24N2O3. Cinchona bark, that is medicine for malaria and swamp fever. These are then morphine, as we know that morphine having as a molecular formula C17H19NO3, and it is opium, sulfonary plants, analgesic to control pain. And the last one is a strychnine C21H23N2O2, strychnoganatic xanthogenic bean, and the properties of this is a resolution of DL acids, stimulant, and increases muscles of the body. So this is all about some alkaloids and their uses we have seen. In totality, for this discussion now, today onward we are going to learn general method for determining structure of alkaloids, similar to the terpenoid. That is the point we are going to learn over here, some of the general properties of the alkaloids. How do we determine the structure of that alkaloid, or how do we derive the structure of the alkaloid, that we are going to learn over here. Right now, let us see that point, general method for determining structure of alkaloids. This is the point we are discussing, general method for determining structure of alkaloid. For determining structure of alkaloids, that is the point which we are discussing right now. Now is the point number 1, that is the point we are discussing over here. What is that? Molecular formula. First point we are learning as a molecular formula. Molecular formula, which is a point we are discussing right now. Here, look at here, a pure sample of alkaloid is subjected to qualitative analysis so that its empirical formula is found out. Then, by determining its molecular weight, its molecular formula is determined. Similar to the terpenoid, the same word or the same steps we are using for determining the molecular formula, for deriving the molecular formula of the alkaloids. So the same, whatever tricks or whatever steps we have used while determining the structure of that terpenoid, same we are using over here. Now is point number 2. What is the point number 2? Will be detection of unsaturation. That is the point we are discussing, detection of unsaturation. And that detection of unsaturation, and as we know that well-known method, there are generally we have used 2 methods. One is a bromination and another one is a hydrogenation. These 2 methods, by using these 2 methods, we completely know how many number of carbon-carbon double bond present in the unknown alkaloids. So that we already discussed in our previous lecture while studying the general method for detection of unsaturation for terpenoids. So same you can use over here. Now third one is a nature of oxygen. Third one is a nature of oxygen. If you look at all the alkaloids which are present, there are oxygen atom is present, and as we know that oxygen may present in the following functional group, or it involved in the following functional group like hydroxy, carbonyl, carboxylic, ester, amide, acetone, lactone, lactam, methoxy, methylene dioxy group, which can be detected as follows. There are some method for the detection of that functional group. Number 1 we are going to consider, one is a hydroxyl group. How many hydroxyl groups are present in the alkaloids? So that we will discuss in the next lecture. Today let us stop today here. Remaining thing we will see in the next lecture. Thank you. Have a nice day.